Well, thank you so much for having me, and thank you for staying. My name is Sumie Nakaya. I come more from diplomacy background than science, having spent 15 years at the UN managing peacekeeping operations. I'm also the one standing between you and your wine and beer at the reception. So I'm going to be concise and talking about disaster resilience technology, and in particular focusing on Japan and the Asia Pacific. Why disaster resilience technology? I think, if you look around, every time we have heavy rains, we have floods, and dry summers lead to wildfires, in addition to earthquakes and tsunamis that no one can prevent. So it's life-saving technology, and Asia-Pacific region is hit the hardest. We already know that the displacement caused by climate change, natural disasters, the numbers surpass the displacement caused by war, violence, and conflict. And 80% of the displacement caused by natural disasters happen in the Asia-Pacific region. And also it's in the context of the rapid urbanization. The mega cities with more than 10 million population, 28 of 33 megacities in the world are in the Asia-Pacific region. And if you can imagine how complicated and challenging it will be to manage crisis in urban context, and that's what we have. And why Japan? Well, obviously I'm Japanese, but at the same time, the 1990s was the UN International Decade for Natural Disasters, and Japan led that movement. It has hosted world conferences on natural disasters, having set the conversations and standards and agendas for disaster risk reduction. And that has the focus of my topic today. All right, well, thank you for putting up the I think one more context that I wanted to put forward about Asia Pacific, that it also lacks the regional integration framework as you have in Europe or North America. And we have still divided Korea's, China, Taiwan, the South China Sea. So in the context of these deep regional divisions, what's the role of the science diplomacy and how that contributes to regional reconciliation and coexistence? I'll highlight maybe 3 areas that Japan's disaster resilience technology have excelled. One is the space diplomacy. In the deeply divided region, interestingly, I think Japan has played the leading role, focusing on technical cooperation, moving away from the security implication. So in the context of remote sensing and space diplomacy for disaster resilience, it convened the regional platform through the establishment of the Asia-Pacific Regional Space Agency in '93, and Sentinel Asia through the regional space framework to have the remote sensing, the satellite imagery available for disaster response and emergency Earth observations. For example, you have the advanced land observation satellites with the synthetic radar SAR with a microwave capable of detecting changes in land surfaces by several centimeters. And now we have the fully automated analysis system to estimate the extent of floods and other natural disasters within 2 hours of the Earth observation. And through Sentinel Asia, Japan and also the member states and participating space agencies, international organizations can exchange the satellite imagery in response to typhoons and floods and so forth and so forth. So that's one concrete example of science diplomacy and in the context of disaster resilience, the risk reduction, working out. And we need these kinds of examples. We spent from 1 o'clock quite some time talking about the duality of technology, the science diplomacy, how it can lead to competition, but also cooperation. And disaster resilience technology is one area that could override the geopolitical tensions and bring the parties together for life-saving purposes. Second, you could then also, in the context of science expertise, you could combine the Earth observation with the data analytics for disaster simulation, detection, and modeling. One example would be the flood prediction can be advanced through the sensor technology for the real-time data observation and processing, and combine that with the rainfall forecasting and water flow trajectories, and combine that with the hydrological modeling of the basin or water conditions, and combine that with that virtual reservoir simulation, so that you can have a pretty accurate and near real-time flood forecasting and early warning. And you could then transfer that expertise and technology through bilateral or multilateral aid system, like official development assistance, to, for example, like Japan has done this in Myanmar, Sri Lanka, and the Philippines and other Southeast Asian neighbors, that you bring this high computer and AI-enabled data analytics technology to the recipient countries, partner with the local research institutions for in situ analysis, so that you can do a capacity building, at the same time build that real-time, the disaster detection framework. I think one more area that I'd like to mention is that the deep dive into the sensor technology, especially in the context of urban management, like the smart cities. So that here, we also talked a little bit about the business, the private sector. Here you can have the corporations like, say, Panasonic, building the microgrid energy system linked to the AI-enabled energy monitoring and analysis system, so that you can have the self-sufficiency energy supply system, but B, you can then also store the locally produced energy and survive in the case of natural disasters. So some of those sensor technology also can be life-saving and preventive interventions. And I think this microgrid system have been used in other cities beyond Japan, like in Denver, where Panasonic also introduced the microgrids similar way. All right. 1 minute. We have spent quite some time talking about what technology can do, but less time on so what? What has changed? Have these technologies actually led to life-saving? And the answer seems to be mixed, if not that encouraging. A few lives have been saved because of amazing technological advancements in the context of natural disasters. Why? We need to link this to behavioral science. We need to also be better at crisis communication, so that the investment in science diplomacy can really be the humanitarian asset that benefits not just our countries, but also beyond. 5 minutes? Yeah? Thank you so much.